We're going to continue our lessons on exponents, and we will start with a warm-up on the next slide. Okay, so for our warm-up, we're going to find each one of these problems. 16 squared, if you use a calculator, you're going to find that this is 256. And 16 to the negative 1. Now that negative does not make a negative number. It means move it. So if it's in the numerator, move it to the denominator. If it's in the denominator, move it to the numerator. And then any number, no matter how small or how large, raised to the 0 power is just 1. Okay, we're going to simplify some numbers. And what you're going to notice about these numbers is that these two examples have square roots. Now it doesn't matter whether your number is a square root or an irrational number like the square root of 2 or pi or any other number. The point is that you can apply the rules of exponents. And so if we have x to the a over x to the b, what we remember is that if your bases are the same, which is x, then you're just going to subtract your exponents. And that's what we're going to do here. The first example, my base is the same, it's 6. So I'm not going to do anything to that, but I'm going to have square root of 2 minus negative square root of 2. Make sure to have that minus the negative. And then we will add those exponents together and get 2 square root 2. Well, we could leave our answer like that, but we're not. We're going to write it as 6 squared to the square root of 2. And the reason that I do that is that 6 squared is also a number, and we can simplify this. So whenever you can evaluate, do evaluate. And at this point, we're done with that problem. Now let's look at the next problem. We have a power to a power. So when we have a power to a power, we're going to multiply those two powers together, like that. And we can look at that as 3 to the square root of 4, but the square root of 4 is just 2, and this answer is 9. Now an exponential function, or definition that we have here, means that we're going to have a number for our base as opposed to a variable, but our variable is going to be in the exponent. And our base is going to be positive, and it's also not going to be 1, because if it was 1 it wouldn't really matter what the exponent was. So this is an exponential function where your variable is in your exponent. Alright, solving exponential equations is 3 steps. Now an exponential equation means that your variable is in the exponent, so we're going to have to figure out how to get that exponent out. Well, we are going to begin by, you're going to rewrite your equation with the same base on both sides. So you're going to have some number on both sides that has 2 different exponents. So what I'm talking about here is if you had something like 2 to the x equals 2 to the 4th, something like that. Then your next step is once you have that, you're going to set the exponents equal to each other. Because if the bases are the same, you don't need them anymore. Really what matters is the exponent. So we will just say x equals 4. And then your last step is to check. And part of step number 2 is and solve for your variable. Okay, and your check, that's important. You can do that mentally, but if you just substitute in what you solved for, you can see that that checks. Okay, we've got 4 examples. The first step that we were going to do is that we are going to rewrite each side of my equation here with the same base. But first, it helps with everything being on the same level. So I'm going to bring that 4 out of the denominator and make this 4 into the negative 1. Now, same base means I can write both 8 and 4 as powers of the same base. And 8 is the same as 2 cubed. But we don't get rid of the x. We're just replacing the 8. And here, the 4, we're not getting rid of the negative 1. We're just replacing the 4. So what you're going to do now is multiply your exponents. And your bases here are the same. So this and these 2's are the same. So we're going to drop those. And just be left with 3x equals negative 2. And when we solve for x, we get x is equal to negative 2/3. And you could check this by plugging this into your calculator and see that x raised to the negative 2/3 power gives you a 0.25, and 0.25 is 1/4. So let's move down to the one underneath this one. And I'm going to start by taking that 32 out of that radical, and I'm going to raise it to the 1/3 power. And we can't just say x is equal to 1/3 because we need to rephrase. We need to make that 32 some power of 2. And it turns out that 32 is 2 to the 5th. And then we have is equal to 2 to the x. And we'll multiply our powers together. 2 to the 5/3 equals 2 to the x. Drop the bases. And then what you're left with is 5/3 equals x. Okay, so let's try the example on the top right. 5 is as small of a base as you can get, but 25 we can rewrite as a 5. So we're going to have 5 squared for 25, and then x minus 1. And here we can actually multiply our 2 with our x minus 1. And so we'll have 5 raised to the 2x minus 2. And we can cancel our like bases. And we will end up with 4 minus x equals 2x minus 2. And then we can solve for our x, which will give us 6 equals 3x. And so x is equal to 2. Now let's try the last one, and then we're finished. Okay. I can rewrite 4 as 2 squared, and I could do 64 as 2 to the 6th. But 64 is also the same as 4 cubed. So you don't really need to go with bases of 2. So use the largest ones that you can. You'll get the same answer. Alright, so what I have here is 4 raised to the 3x. Now I have 2 bases that are the same, so I'm going to cancel those out. And then I will have x minus 2 equals 3x. Negative 2 is equal to 2x. So my x is going to be equal to 1.